Today we're going to be doing exponential growth and decay models. So you're going to have word problems. They're going to be real world problems, but I promise you, just don't overcomplicate and you will be fine. We're going to use this poster over here I made with the growth and decay formulas. We're going to use both of these formulas here. For the first one, A equals P 1 plus R to the t value. That's kind of what this box right here is talking about. So we're just going to simplify and just have the formula. P is going to be your principal amount. Or in other words, the amount you start with. All right, so principal amount, the amount you start with.
Is that L plus R?
1, that's a 1. I'm sorry.
Oh, no.
That's a 1. So P is going to be the amount you start with. R is going to be your rate. It does need to be a decimal. All right, so R is going to be your rate. It needs to be a decimal. And then T, of course, is time.
Can I borrow one of your markers?
All right, so P is what you start with. R is your rate. It's got to be a decimal. T is your time. Another thing you're going to use to find the rate is this fraction right here. Your final value minus your initial value over your initial value. That will also tell you the rate. So we're going to have both of those guys. So that's kind of this first part right here. For the second chart, you're going to have two types of exponentials. You're going to have a growth and you're going to have a decay. So an example of a growth would be like population. The population is 1 million and we are growing exponentially. So say we're growing at a rate of 10%. How many people will there be in the world in 5 years? Something like that. You're growing. You're getting bigger. Does that make sense? So if you're getting bigger, your rate is going to be positive, right? Because it's growing. It's getting bigger. So if this guy right here, the B value, if it's bigger than 1, you have a growth. All right, so if the base, the B value, if it's bigger than 1, it's a growth. Because R would be positive.
And if it's less than it's not a growth.
It's a decay. And so an example of a decay would be like a car that you buy. You know, when you buy a car, as soon as you drive it off the lot, it starts losing value, right? And the older it gets, the more value it loses. So a car would be an example of a decay. And if something is losing value, the rate's going to be negative, right? So negative rate means that you're getting smaller number. Positive rate means that you're going to grow. So if your rate here is negative, that means that B is less than 1, and it's a decay. So bigger than 1 is the growth, less than 1 it's a decay. So that's kind of this whole chart right here. Okay, so for this first part, just as analyzing the exponential functions, I want to determine whether it's a growth or a decay. So I'm looking at the B value, not the first number. The first number is your starting value, your initial amount, right? So that doesn't matter. I'm looking at the number that has the rate, this guy right here. If it's bigger than 1, it's a growth. It's less than 1, it's a decay. So what is this one? Decay. What is this one? Growth. What about number 3? Growth. Then decay. And then decay. All right, so those numbers there are what you're looking for growth and decay. Does that make sense? Perfect. Okay, moving on. Writing exponential functions. So this is where we're going to use that formula. I'll write it again right here. A equals P 1 plus R to the T. So there's kind of two parts to these problems. The first part, it says write a function that models the growth, and then it says how tall will it be at the end of 14 years. So there's kind of two parts here. For the function part, we are filling in stuff for the P and the R, and we're going to write it in terms of time. And then that way you could always say, okay, well, how tall would it be in 15 years? How tall would it be in 16 years? The time is what's changing, but the starting amount and the rate will stay the same. Does that make sense? How that would be the function? All right, so what is my starting value? 3, and then my rate? Good. So the rate right now is 8%, but remember you need it as a decimal. So we're going to take this decimal, move it to the 2 spots to the left. So the rate we're going to plug into the formula is 0.08. A weird 0. Yeah. All right, so that's my function. And then it says, okay, how tall will the tree be at the end of 14 years? So where are you plugging in 14? Into the T. And we're not doing these by hand, nor will you ever have to do these by hand. So we're just going to plug them in. 3, 1 plus 0.08 raised to the 10th power.
Will it ever try to trick you and it says 8% each?
Oh, not 10, 14. Why did I put 10? 14 years. Will it ever try to trick you and do what?
Be like, what is it? 2 months, and then it gives you the rate of the year.
Not in this class. All right, so after 14 years, it would be 8.81 feet. All right, so any questions on that one? All right, number 7 is a little different. We are still going to write a function, so we still need to figure out our starting value and our rate. So a motorcycle purchased for $9,000 in 2014 was worth $8,460 in 2015. Write a function that models the value for what can you expect to sell the motorcycle at the end of 5 years in 2018. So what is my starting value? 9,000. And then does it give me a rate? No. So this is where you're going to have to use final value minus initial value over initial value. So what would be my final value? 8,400, because a year later your final value of it is 8,460 minus your initial value, which is your starting value, 9,000, over your initial value again, 9,000. Does that make sense? Okay. And so we're going to plug in the calculator. 8,460 minus 9,000 over 9,000. And I get negative 0.06. So my rate being negative, does that make sense? Yes, because my value is getting smaller, right? I started at 9,000 and then a year later it's down to 8,460. So it's getting smaller. So your rate should be negative 0.06. Okay, and so now for what can you expect to sell the motorcycle at the end of 5 years in 2018? So what are you plugging in for T? 5. So my calculator, I'm going to do 9,000, 1 minus 0.06 times 5. Or raised to the 5. And so in 5 years, your motorcycle is only going to be worth $6,605.14. Mm-hmm.
On the beginning of this part A,
Yeah.
that doesn't make any sense. Why is it 14 times 0.9? Why did it 64? Oh, never mind. Wait, yeah, never
This one?
Yeah. Why did you say that?
If you wrote it out like the long way, 14 is what you start with, and it would be 1 minus 0.05. Does that make sense?
Yeah.
Because
Can you write it like that?
Can you?
Like how the example is?
Like, could you actually work out 1 minus whatever your rate is?
No. Can you write it like that without the 1?
Yeah.
Oh, okay.
They just combined. They just did 1 minus 0.05 and got 0.95.
Oh. Okay, now I get it.
You see what I'm saying?
Yes.
Okay. All right, flip it over on that. I'm going to skip 8 and 9. They're just like the 2 previous examples we did, and we're going to come down here to part C. So part C, we're going to use the other formula here I have on my poster. It's called the PERT formula. You are going to use the PERT formula when you see these 2 words. You have to use the PERT formula when you see the words compounded and continuously, or continuously compounded. If you do not see these 2 words, you cannot use the PERT formula. It has to literally say those words. The A, the P, the R, and the T, they all mean the same thing. So A is going to be your actual amount. You know, the ending amount. P is going to be the start, wherever you start, your initial. R is still going to be your rate. Still need it in decimal form. And T, of course, is time. So all of that stuff stays the same. This is used a lot in banking. Like if you were to deposit $100 into the bank, you get interest, right? Normally banks don't do interest like annually, which means you have $100 in, you're going to have $100 forever in the bank. Just straight $100 until the end of the year, and then they calculate the interest. And then now for the next year, you're going to have like $105 in the bank because you got $5 of interest. And so for the rest of that year, you have 105. It normally doesn't work that way. Normally you'll have the compounded continuously, which means that they're continually adding interest. Does that make sense? Like how if you... Yeah, and that's why when you go, it's like, I got 3 cents. It's just because it's like continually added. So by the end of the year, it might make like $1 or something. But and then the more money you have, the more interest you'll get. But so this is when you kind of use it more like banking wise and stuff like that. So number 10 says, suppose you invest $1,050 at annual interest rate of 5.5 compounded continuously. How much money to the nearest dollar will you have in the account after 5 years? So for the PERT formula, A equals P E to the RT. What is your starting value, your principal amount? 1,050. And then I have E. For the rate, what is the rate? 5.5%. And so when I turn this into a decimal, it's going to be good, 0.055. So 0.055 for my rate times the time, which is 5 years. And so then all we're going to do is plug it into the calculator. All right, this is very important, so make sure you're looking up here. You cannot use this E for this E. Cannot. It does not work. This E is not a special E. It is just a regular variable E. It tells you nothing. All right? It is a variable. This is a special E. It is called Euler's number. There are 2 spots you can get the E. The first spot, which you might already see, is this E right here. And you see when you type it in, it's bold. All right, so it's a bold E. So that's one spot you could get it. You can also get it down here where your pi symbol's at. That's kind of all your special symbols. So you got pi. You have the I when we did complex numbers, the imaginary, right?
Oh yeah.
And then the E. So these are all kind of. Where? What else? Yeah, there's lots of. This one? Or is it the other one? The book? Where is it? Oh, yep, there it is. There's also there.
Whoa.
So, but the special thing is what you're looking for is it's bolded. So if it's bolded in your calculator, you know you did it right. So we're just plugging this in. 10, 50, Make sure you get the Euler's number E. 0.055 times 5. Right, and so rounded to the nearest dollar, we would have about $1,382. All right, I'm going to do number 11, and then I will be done. Yeah. All right. So, still using the PERT formula because it says compounded continuously right there. So it says suppose you invest $1,300 at an annual interest rate of 4.3% compounded continuously. Find the amount you'll have in the account after 3 years. So what is the P value, the starting value?
1,300.
What is what? What? The formula? Is that better? Okay. E, and then the rate is 4.3%, right?
Yes.
So the number I'm plugging in is 0.043. And then the time is 3 years. So in the calculator, 1,300 E 0.043 times 3. And I get 1479.